Okay, so let's talk about the normal distribution, or section 5.4 in your notes. So it says that to keep in mind that a set of data that is normally distributed has a symmetrical bell shape when graphed as a frequency polygon. So that's the reason why you've had to make those histograms and then pick the middle of each of them to make this frequency polygon. Okay, symmetric bell shape means that it looks something like this. Okay. Generally, measurements of living things like mass, height, and lifespan have this type of distribution. And the properties of normal distribution, this is important, the properties are, first of all, it says that the mean, the median, and mode are close to equal and fall at the vertical line of symmetry. So right here is the vertical line of symmetry. So your mean is right down the average. And it says the mean and the mode are fairly close to that as well. The amounts of data within 1, 2, and 3 standard deviations of the mean are shown on the graph, and the area under the curve can be considered as equal to 1, since it represents 100% of the data. All right, so let's go over this a little bit more. And on the next page, all I did was recopy it. And so this is a normal distribution graph, okay? So notice down here, right in the middle, it says here's the mean, okay? So based on the middle of the graph, it means that 50% of the data would be to the right of the mean or above it, better than or higher. And then 50% would be below. So if you took 34 and you added 13.5, you added 2.35, and then even though it doesn't show it to you on here, there's a tiny little 0.15. You would get 50%, okay? So 50% on this side, 50% on that side. Now, this section here, I'll just color it yellow. This section here should represent, as long as your data is normally distributed, should represent 34% of the data. So, and the way that they calculate this section is they take whatever the mean is and they add a standard deviation, okay? Then the next section, where 13.5% of the data should fall, is the range from the mean plus 1 standard deviation to the mean plus 2 standard deviations, etc. Okay, so let me erase all this stuff, and then let's start from the beginning. So right down the center is your mean, 50% above, 50% below. 68% of the data fall within 1 standard deviation above or below. 95% of the data will fall 2 standard deviations above or 2 standard deviations below the data, and practically all of it, 99.7%, almost everything, will fall between 3 standard deviations above and below, as long as they tell you that the data is normally distributed. I'm not saying all data falls like this, of course it doesn't, but if you're told that the data is normally distributed, then you can assume that the data will look like this. Or if the data looks like this, then you can say it's normally distributed. All right, so the example in your book here talks about the ages of grandparents of Elaine's classmates were collected, okay? So there are a total of 32 people in this class. There must be, because there's 32 numbers. So all the ages of the grandparents of Elaine's classmates are collected, and it says, does the data approximate a normal curve? They're asking you, is it normally distributed? Is what it's asking. So what you got to do is you got to figure out, does 68% of the data fall 1 standard deviation above or 1 below? Does 95% of the data fall 2 standard deviations above or below? Does it look like a bell? And so if you can answer all those things yes, then you would say, yeah, it is normally distributed. If the answer to those are no, you would just say no, it's not. So we need to graph it in a frequency polygon so that we can look at the curve. And we also need to create a frequency chart so we can see what amounts of data fall above or below the mean. Okay, so what we need to do is calculate the mean, and we need to calculate the standard deviation. So go to the web page, go to the basic stats calculator. I made a sticky note of all the data just to save time. Those are all the ages of the grandparents. And so it says, and by the way, you should always be checking this. Are there 32 numbers that you typed in? Because if this said 31, you made a mistake, and you have to figure out what you got wrong. So we typed in 32 numbers. The mean is 72.1. The standard deviation here is 7.4. Okay, so the mean was 72.1. The standard deviation was 7.4. So I know there's not a lot of room in your booklet, but I would like you to somehow copy out this table. And so what I'm setting it up for is I want the mean in the middle. You actually can just do 6. You don't need to do these 0.15s because I'm not doing them. I'm doing 1, 2, and 3 above and 1, 2, 3 below. So set up the 6 by 3 table. And these percentages are just from this, 34, 13 and a half, 2.35. Okay, 34, 13 and a half, 2.35. So I want to set up a bit of a frequency table, and we calculated the mean to be 72.1, and the standard deviation was 7.4. So this range for my frequency table will be from 72.1 to 79.5, because this is the mean, right here's the mean, okay, and then all the way to 1 standard deviation above. So 72.1 plus 7.4 is 79.5, okay, so that's where that range came from. The second range is going to be 2 standard deviations above, so it's 79.5 plus 7.4, and then 3 standard deviations above, 86.9 to 94.3. So instead of picking just random intervals that we could put all this data in, like 60 to 65, 65 to 70, 70 to 75, etc., why not make our ranges or our intervals 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, okay? So that's where these numbers came from. And if you got to pause in order to write this down, please do that and then come back. This will be 1 standard deviation below, so it's 72.1 minus that 7.4. So this range is 64.7 up to 72.1. 2 standard deviations below and 3 standard deviations below, okay? So these are the ranges. So then what you need to do is you need to look at your table and you need to figure out where each of the grandparents' ages fit. What range do they fit in? So the first range, if you look on your table of Elaine's classmates, was 65. And so 65 would fit in this because 65 is more than 64.7 and it's certainly less than 72.1. So you'd put a tick in this box, okay? The next age below is 85. 85 goes here. The next stage is 72, which barely fits in there, but it does. And then the last of that column was 65, which goes here, okay? You would do that for all of the columns. Remember, there's 8 sets of 4. And that's the way that you could get the frequency. So this section's like the range or the interval. And then below is the frequency. How many times did a grandparent's age fall in that range? Again, I didn't bother for the little tick below and the little tick above, okay? So I've already gone ahead and added it. I'd like you to pause here, though, so that you can make sure that you know how to figure out a frequency table. So pause and come back, and because I will ask you to do that on a test. This is a question similar to that you have on your chapter test, where I ask you if data is normally distributed. So pause, finish up the frequency, and come back. All right. So starting with the first, let's start here with a standard deviation above. Okay, so I said that 8 numbers in that 32 numbers given by the ages of the grandparents of Elaine's classmates. There were 8 that fell between 72.1 and 79.5. There were 13 that were 1 standard deviation below. There were 5 that were 2 standard deviations above. There were 4 that were below, 1 and 1. Okay, so hopefully that's what you got in terms of numbers of ages of grandparents. You should total them up. They have to add 32 to 32 because 32 ages were given up. We have 5 plus 13 is 18, plus 8 is 26, 31, 32. So we're good. Okay. So let's check out, first of all, the 68% of the data fall 1 standard deviation above and below, because that's one of the criteria of a normal distribution. So remember that there were 32 ages, and 8 were below, 1 above, and 13 were below. So what we need to check is what percentage is 13 and 8 out of 32. Oops. 32. So remember, there were 8 1 standard deviation above, and 13 were below. So 13 plus 8 is 21. I'm going to get on a calculator. I don't have time to pull one up. I'm just going to use the one that's sitting on my desk. 21 divided by 32 is 0.656, which works out to 66%. Okay? So, roughly, would you say that 68% of the data fall within 1 standard deviation above and below the mean? I'd say yes. We're pretty darn close with 66. Now, does 95% of the data fall 2 standard deviations above and below the mean? Okay, this is the section. This is 1, 2 above, and this is 2 below. Okay, so we got to see if 4 plus 13, 4 plus 13 plus 8 plus 5 out of a total of 32. I did it again. 1 sec. Okay, so remember this 13 and the 8 were 1 standard deviations. We've added 2 standard deviations. So 13 and 8 were 21, plus a 9 is 30. 30 over 32 works out to 0.9375, which is roughly 94%. So, yes, I would say fairly close. So based on these two things, I could probably say that they're normally distributed. However, I just wanted to plot the data on a histogram. So I went ahead, I went to this one, the online graph maker. I went there, okay, to make a histogram, and I plugged in the data, and this is what I got. So notice my ranges, 49.9 to 57.3 is this, 49.9 to 57.3, then 57.3 to 64.7, etc. So these ranges came from my frequency chart. Remember, my first number was 1, then it went to 4, 13, 8, 5, and 1. Okay, so all I did was translate those numbers into a histogram. And then to make that frequency polygon, all you do is you find the middle of each of the bars. And you could probably visualize it without having to do that, but I'm going to go ahead and do it anyway. And then you connect the lines, okay? So I'm going to go here to here. Whoa, that's a thick line. Here to here. Here to there. There to there. And there to there. Okay? Would you say that this is similar to that picture? Okay, that picture I massacred. How about this picture? Would you say that my frequency polygon resembles a bell curve? And I would say, yeah, it does. It rises, it peaks, and it comes down. So that's the second part of evidence that I could say that, yes, the data is normally distributed. Okay? So that's all there is for section 5.4.